we come to a very important logical concept which turns into a gate called AND. And another way of understanding AND is the same as saying both or all inputs are true. And if you remember, that's the same as saying they're all one or yes. They're all equivalent ways of understanding it. In this video, what I'd like to do is map that structure out. I'm going to do it in a slightly different way so we can work our way through the concept. First of all, let's start with the mathematics, because in this case, in the case of not, let's just quickly go back over. In the case of not, we had to introduce a new notation. We had to say the output value was the input value inverted, and I used an apostrophe. So mathematically, that was a new concept. But in the case of an AND, we have a very old and very familiar mathematical process. I'll write it down and explain it. What does that mean? A and B are your two input values, and they're multiplied. The values, the numbers, the ones and zeros, whatever occupies them, are multiplied to give you your output. What happens if we do that and we do it systematically? So what happens if we take A as one input value, B as the other, and X is our output? Using the multiplication, X is the product of A times B. What values do we get? Well, let's go through the combinations that we might have. A could be 0 and B 0, because 0, 1, 1, 0, and 1 and 1. Okay, let's extend that line down there. Okay, so for each combination, let's put them into this multiplication, and the output is the result. So let's have a different color. So 0 times 0 multiplied together gives you 0. 0 times 1 gives you 0. 1 times 0 gives you 0. 1 times 1 gives you 1. That, both mathematically and logically, explains or defines the AND gate. So AND gate, as I said, or I might have said, or you should understand, both or all values have to be true for the output to be true. It's a very restrictive condition. You know, if one of them's true, but you have a 0, so one of them switched off, let's just take that we are saying these are switches, okay? If these two values represent two switches in a circuit and both of them are switched off, then the output will be switched off. If only one of them switched off, it's still off. One's on, still off. Only both, when they're on, will switch it on. Let's have a look at what that might look like. From a computer gate point of view, you get a flat line with a sort of extended half circle. So let's say that we have two inputs, and the output is a light bulb, which I'm going to try to draw in a really bad way. Okay, so under what condition would that light bulb get lit? What values would A and B have to have? Using this thing in the middle, which is, I'm just going to write it down, an AND gate. Well, as the table from previously said, the only combination that will switch them on is if A is 1 and B is 1, because the AND gate actually works by multiplying all the input values. If they are both true, and we could have 20 of these inputs if we wanted, all coming into the same AND gate, but if one of them was false, then the whole lot is false and the light bulb won't be lit, or that signal or message won't be activated, right? They all have to be true in order for the output to be true. And that's a very, very common concept that you have. It's a very powerful one. And we use it. Let's see if we can give you an example of how we use it in some practical way. Imagine I have an AND gate here, and I have the output, and the output sends a warning light. of some kind, right? Flashes up some kind of warning light. I have one input here, A, which I'll talk about in a second, and another one. I'm going to bend it here, because what I'm going to say is that this value, B, can act as a control. Now, I'll tell you what I mean. Let's say that A is some random value. It's sometimes 1. It's bouncing between 1 and 0. 1, 0, 1, 0, 1, 0, and it's pouring in here. The warning light won't go on unless I turn this one on. So this value here could be oscillating. Okay, let's use a different color. Oscillating. It could be, let's say it's heartbeat, or it's something which goes up and down, right? So it could be having this behavior where it's bouncing between 1 and 0, if you can see that. And it's passing that into here. The warning light, okay, we're not going to worry about the situation too much. The warning light won't be activated if B is switched off. If it's switched off, it holds a value 0. Because we know both A and B have to be switched on in order for this light to shine. So this is just bouncing up and down, 1, 0, 1, 0, 1, 1, 1, 0, etc. We don't know. It's a sensor, it could be, let's say, okay? But in order to actually activate this, I have to switch this one on. And by switching this one on, right, so this is now permanently pouring in the value 1, right, because I've switched it on. This 1A value is going 1, 0, 1, 0, bouncing around because it's taking some input data, right? It's randomly fluctuating. But every time a 1 travels down here, the warning light is activated. If it's just zeros, it's going to be switched off because this is now fixed to 1. And this is often used, this logic is often used to control systems. This B value becomes a control switch. A can be a sensor pouring into the system, and then you use it in this way. I'll stop there. Thank you very much.